We are going to start series on physics of class ninth. Now you know that there are few changes have occurred. So we will start with the first chapter, which is motion. Now the very first topic is of reference point and the motion. How you define a motion? You can say that a flying object, a flying bird, a flying aeroplane can be considered as a moving object. If you are walking, then it is also moving. But as far as science is concerned, there are certain things which need to be learned before we can define motion of an object. So here I have taken an example of a symbiotic relation between a buffalo and a bird. Now suppose a bird is sitting on the buffalo and buffalo is moving. You know that this is a very clear and good example of symbiotic relation where both the organisms benefit from each other, have certain benefits. But how to use this here in motion, you would be quite amazed to know that what it is doing here. Actually what we are going to learn is the reference point, the observer, and the motion of the object. We are here to observe what is happening during the movement of the buffalo. When buffalo is moving, what is happening? That you say that the bird is sitting on the buffalo, so both of them are moving and both are in motion. So we are standing on the ground. However, if you take bird as an observer, then what will happen? You will say that the bird will say that it is not moving with respect to buffalo, it is at rest with respect to buffalo, or buffalo and both bird and buffalo are at rest. So we can explain this also using a pictorial representation. So here you can see that there are two pictures which are depicting what is happening. In the first one, the man is the reference point, and the man say that buffalo and bird are in motion. So both of them are in motion relative to man. In the second case, the reference point or the one who is observing what is happening is bird, then it would say that it is not moving with respect to buffalo, or buffalo is not moving with respect to bird. Sorry, buffalo is not moving with respect to bird. So the second picture represents that the both the buffalo and the bird are at rest. So which of these statements are true? You can say that both the statements are true. The change is that reference point or the fixed point has changed. What How you define motion? Motion is defined if an object changes its position with reference to a fixed point. So here the reference point was man, so both the buffalo and the bird were moving with respect to man. However, in the second case, when bird is observer or the reference point, the definition totally changes and it says that the bird is not in motion with respect to buffalo. The bird is not changing its position with respect to buffalo. Now we would move on to some other examples. You can just hear it.
Today, we're tackling a simple question about motion, but, well, the answer's kind of surprising. Okay, let's dive in. Look at this person running on the train. How fast would you say they're going? Actually,
So the first
how
example
fast would you
here
say they're going?
in the video is that this is a picture representing object A, reference point 1 and reference point 2. Reference point 1 is the train and the reference point 2 is the man standing on the ground. Whereas what we are observing, both the references are observer. So what we are observing, the object A, the man who is running on the train.
They're going. Actually, that's a trick question. Right now, it's impossible to answer. We're missing a key piece of info. That missing piece? It's called a reference point. It's basically the spot you're measuring from. So let's pit one. What if our reference point is the person standing still on the ground? From down there, you add the runner's speed and the train speed. Whoa, they look incredibly fast. But what if we change our reference point? Now imagine you're standing on the train next to them. From this view, it's totally different. They're just moving at a normal jogging pace, right? So which speed is correct? Here's the cool part. They both are. It all depends on your reference point. This gets at a huge idea. There's no such thing as absolute motion. It's always relative. You experience this all the time. Think about being on a plane. Your drink seems perfectly still. But relative to the ground, that same drink is blazing past at 500 miles an hour. And that leads to a final mind-bending thought. Right now, you probably feel like you aren't moving. But you're on a planet that's spinning and hurtling through space, so how fast are you really moving?
So in this video, what is explained,
they look
first
incredible.
picture, the reference point 1 train, and you are standing over the ground, the reference point 2, it would appear as if the person is running at a speed of 60 kilometer per hour, because you are adding both the velocity, both the speed of train and the object.
Incredibly fast. But what if we change our reference point?
But if the
Now imagine you're
person
standing.
if the person or the observer is inside the train, it would appear that the man is moving with the speed of 10 miles per hour. Similarly, there are other
You
examples.
experience this.
A drink placed over the table in an aeroplane appears to be at rest for you if you are inside the aeroplane. However, if you are standing at the ground, then it would be running at the speed of 500 kilometer per hour. Similarly, our solar
Mind-bending thought.
system, our earth is revolving around the sun with a very fast speed. However, we do not feel it, and we are also moving with the earth, so therefore we appear as if we are at rest. So these are the few examples that you can, so that you know that what is the reference point and how the definition of motion changes with the reference point. We would now have another way out to understand. Now here the mechanics of perspective, why truth in motion depends entirely on where you stand. So this only is giving you an idea that if you are inside the moving object and if you are outside at a fixed position, then the motion is different. For a person who is running at a speed of 10 miles per hour, you would say that if he is running on the train, the total speed of the train and the man considered would be of 60 miles per hour. So here it is showing the man is running at the speed of 10 miles per hour. After that, a man running on the train is at 50 miles per hour. So if you are standing inside the reference point, the train is absolutely still, and object A, that is the man, is running at a speed of 10 miles per hour. However, if you take the observer at the ground, then it is running at a speed of, total speed of 50 miles plus 10 miles, that is 60 miles per hour. So how would you conclude that these equations are mathematically correct? So these both the statements are correct because we are changing the reference point, changing the fixed point, so the speed also the definition of the total speed also changes. So you can have a conclusive idea regarding reference point 1. The state of anchor, or the person standing inside the train would see him running at a speed of 10 miles per hour, and if a person is standing or at the ground, it would be 60 miles per hour. So in a way you can say that motion is relative, and motion is the change in position of an object with respect to certain fixed reference point. So if the reference point changes, the motion or the definition may also change. Now you can have certain questions with a flashcard. Here it is, what is relationship between observer and the motion? So observer is the one which is reference point, and motion is the change in position of object with respect to observer. So we can see the answer. The observer serves as the reference point to define the motion. We take next question. If you pick a notebook from a table, it is in motion because its position changes with respect to you or with respect to table. So you can say that with respect to table, the book would be in motion compared to it. What phrase does the text use to describe the state of buffalo relative to the bird? So it is the state of the buffalo relative to bird is at rest, or you can say that, you can see the answers from here, it is at rest. The text states that if you change the reference point, the dash may be different. That is, the definition of motion may be different. Or you can say that the state of motion may be different. So this is how you can check your knowledge using cards, that what is the reference point, what is motion, and what is relative motion. So I think we conclude this here only.